Hi guys, welcome to Geek Coding Academy. Today we'll see Collection Framework Chapter 6.4, that is Queue and Deque interfaces. So in our previous video, we covered list interface, set interface, and also the overview of collection framework. So if you have not watched those videos, please watch those videos prior to this. In the today's session, we'll talk about on Queue and Deque interfaces. So let's get started. So what do you mean by Queue and Deque interfaces? So first I'll explain you the structure. In a collection framework, we have two main interfaces. One is collection and one is map. Under these collection interfaces, we have a sub interfaces. One is list, another one is set, and another one is queue. Under this queue, we have a one more interface called DQ. Okay. So list, set, queue or DQ. These are all the interfaces. For them, we have a child classes or implementation classes. So using those, we can easily manage our data. Okay, store and manage our data. So for list, we have a particular type of goal. If you want, in order to make our data into a particular format, we go with a list. And for set, like suppose if we were storing a data, we don't want a duplicates, and we rather don't care about insertion order, we go with the list implementation classes. But what about Q and DQ? Let's see. So it's a part of Java collection framework. So like Q and DQ gives us a specific direction in adding and removing elements, okay? Which will be used in scenarios where we are requiring like ordering, prioritizing, or double-ended processing. Suppose we in a list, suppose in a collection, we want to process data on both the ends, from the front and from the back. So we can use a DQ. It's a double-ended queue. If you want to process data from one by one, we can go with the queue. Okay. So it's all about how we store and how we retrieve our data. So if you want uh, only prioritizing how we need to store and retrieve our data, we can easily select this Q and DQ interfaces or implementation classes. We'll see more on this. Okay. So first we'll see what is Q interface. Okay. Q interface means you consider it as a normal queue. Suppose you want to buy a ticket for a cinema, there will be a queue, right? Like people will be standing in a line, and the first come person will get a first ticket. So it will be like FIFO, means first come, first out manner. So it represent a collection which designs holding an element to processor typically in a queue pattern, but does not necessarily like order elements in a FIFO manner. Okay, where elements are inserted in tail and removed from head. But there are some exception. However, like its own implementation, like priority queue, that will not exactly follow this FIFO order. It will go with the priority of a value in a natural order. Suppose like in an ascending order by default, if you not provided any custom comparator. Okay. So except priority queue, all other implementation classes of this queue interface will follow FIFO order, like first in and first out manner. It's follow the queue nature of data. Okay. So key characteristic of queue is element are added in tail and removed from the beginning head. And FIFO behavior is typical except priority queue. For all other implementation classes, it's like a first out, first in and first out order. Some implementation allow null elements, for example, linked list, but some like priority queue, it does not allow sorry, null values. So let's see what are the common methods available in this queue interface. So some of the common methods available in queue interface are offer. So offer means like how we have in list and set add. Similarly in queue and DQ, offer means we are trying to insert a specified element into a queue. So it will return true if it gets inserted or false if the queue is full. Okay, poll means it's a method. In poll, it will retrieve and removes the head of the queue, means first element it will retrieve for us, and it will also remove that first element from the queue, or return null if the queue is empty. Peek. Peek means it will retrieve the first element, but it will not remove the head of the queue, and returns null if the queue is empty. Remove. Remove means it will retrieve the head of the queue and also removes the head of the queue, but it will throw an exception if the queue is empty. Okay. So what are the common implementation of queue interface? So queue interface have many implementation classes. I'm writing here some of the common implementation. So for queue interface, we have a linked list and priority queue. So you may wonder, linked list we already discussed in list interface, right? Yeah, linked list is so versatile that it will implement both list and queue. And also in DQ also we may see this linked list. So the linked list will act as a list also, and it will act as a queue and DQ also. We'll see that. So yeah, the linked list and priority queue is the common implementation of the queue interface. The linked list implements both list and queue. So it behaves as a FIFO when it's written under queue, and it behaves as a um, like both FIFO and LIFO means last in first out when we return under queue DQ interface. Okay, and also the insertion order is preserved when we link list we used under list. What do you mean by priority queue? Like order element based on their natural ordering. That means like value of an element, it will sort it from ascending, but it will not guarantee you that it will sort at a one shot. In priority queue, we add the values to it when we are retrieving a value using in a poll method. So it will always give us the lowest valued. Suppose if you are adding an integer, it will always give you the lowest value of an element present in the entire collection. Means it will sorting in ascending order, but it will not sort at once. Like it will be sort at the time of retrieval. Okay, so it will. That's one of the concept. We'll see more on priority queue. We can use custom comparator also. While at the time of constructing this priority queue, we can give our own custom comparator where our own rule or logic in order to sort the data available for this priority queue. Let's see another. Let's see what you mean by DQ. So unlike queue, DQ stands for double-ended queue. It's a subtype of queue interface and it allow element to be inserted or removed from both ends. Okay. Unlike regular queue, which usually follows FIFO, I already told it just like a queue, like first in and first out. D can operate both first in and first out also, and last in and first out also. That means like both the end of the both from head end and tail end, we can remove the data or we can process data. Okay. So this LIFO last in and first out will be like stack. Suppose like I already discussed in my previous videos. Stack means like a stack of books. Suppose you want to keep a books on top of one another. Suppose you want to retrieve a book. So you'll take out the first book, right? That first book will come end. Like when you're stacking the books. So at last, what book you kept it on top, you will take that book first. That is what called stack concept. Like both these DQ follow like both like when we are removing a last in first out or first in first out which will be queue and it will act as both as stack also. What are the key characteristic of DQ? We'll see. So it will support insertion, deletion, retrieval at both the end, both the side we can do all these operation both head and tail, and it can function as a both queue also FIFO and stack also like LIFO last in first out, and does not allow null elements. Only linked list will allow a null element. Other implementation of these Q or DQ interfaces does not allow null elements. So common methods in DQ interfaces add first. We know by like both addition and removal can be done on both ends. So that's the reason we have this add first. Means it will add the element to the first front of the DQ. Add last will be add the element at the end of the DQ. Remove first is removes and returns the first element of a DQ. Remove last is removes and returns the last element of DQ. Pick first means retrieves but does not remove the first element of DQ, or return null if the DQ is empty. Peak last is retrieves but does not remove the last element of DQ and returns null if the DQ is empty. So what are the common implementation of DQ interfaces? For queue interfaces, we see linked list and priority queue. For DQ interfaces, similarly, we have a linked list and array DQ. So linked list can be used for both list also, queue also, and DQ also. That's versatile it is. And array DQ. is one of the common implementation for this DQ interface. What do you mean by array DQ is a resizable array implementation of a DQ interface. We have an array, it will be resizable, and it is more efficient than linked list for implementing both stack and queues. Means both FIFO and leaf order, first in, first out, and last in, first out orders. For linked list, it is also implements DQ interfaces, but it performance may be slower because linked list, the type of like the way of storing a data is little different, right? So that's the reason compared to an array. It will be slower compared to a array DQ because it's backed up by linked list. So it will work similar to a linked list. Okay, we'll see Q and DQ implementation in detail. First, we'll see linked list because it will be act both as Q and DQ also. Then we'll go with an array DQ, means it's a implementation of DQ interface. And we'll see about priority queue. It's a implementation for queue interface. Linked list. So linked list class is a versatile data structure that implements both queue and DQ interfaces. When used as queue, it functions as a FIFO queue, means first in, first out. That's a queue nature. When used as a DQ, it supports both queue nature and stack nature. That is, both FIFO also it will work and also LIFO also. Means the operation at both ends, front and back of the list. So let's see the syntax. Queue be aware of linked list, FIFO, that first in and first out. Okay. Here I created a class, a public class. Under this I have a main method. I created a linked list. This object I am passing to a reference variable q, which is of type q here. Passing this object to a reference is more important here, guys. So if you create a linked list and pass it to a list reference, it will act as a list. If you pass it to q, it will act as a queue, and it will pass the reference to dq, it will act as a dq. So here I'm passing it as a queue. So queue has some of the common methods we saw there. Like offer means addition of uh, this data to a collection. Q dot offer John, Q dot offer Jane, Q dot offer Jack. All three data I'm just adding to here. When I print out this, I'm get John, Jane, and Jack. So poll is to retrieve the first element and also remove the element from the list. When I do that Q dot poll, I get the output of John because I inserted in this order John, Jane, and Jack. I removed the first element John. So when I print the remaining collection Q, I get this other remaining values Jane and Jack. So here John I inserted first. When I removed, the John came. Like first in, first out. A queue nature complete. So element are inserted at the end and removed from the beginning. Okay. Usually when you need both list and queue operation combined, it will be like both list and queue operation combined. Okay. Let's see DQ behavior of linked list. Same classes I created, same main method. And here in linked list, once I create this object, I pass the reference to DQ, which is of type DQ, and the data I'm going to store is string. That's a refer I'm noting here. In DQ, we have a other methods like add first and add last. Add first, I inserted a first data as first, and I calling an add last method to insert a data last. Okay. When I print this DQ, it will come as a first and last. While retrieving DQ dot remove first, I just removed the first element, and also DQ dot remove last, I get the last element and remove that last element from the list. So it just like both the ends we can able to process this addition also, both the removal also. So elements can be added or removed from both ends. That's what we call it a double-ended queue, and can be used for both FIFO, that is queue nature, and LIFO, last in first out, that is stack nature for processing. So let's see, we saw the linked list. Let's see another common implementation of DQ, that is array DQ. So array DQ is highly efficient implementation of a DQ interface. So why we can use a linked list only, right? So why we need to use an array DQ? Because it provides a resizable array, which means it's a most efficient than linked list for both stack and queue operations. Okay, especially when used as a leaf or stack or FIFO queue. Let's see the its syntax. So for my main public class under a main method, I created an array DQ object which I passed it on to DQ reference variable, which is of type DQ, and I'm storing in a string data up here. I'm notifying here. So using as a queue, like for queue means first in, first out. So I just add a data at the last, offer last, John, Jane, and Jack both are added at the last. While retrieving, I retrieve the first element. So when I print this, John, Jane, and Jack will be added. While retrieving, I'll use a poll first method to retrieve the first element. So I'll get like John, Jay, and Jack. This will be first in, first out. Okay. Let's see what is the last in and last out. So I can use this. There is a push stack methods. Push means adding a data. So dq.push Tom, dq.push Jerry. What it will like, first it will add the Tom. On top of that, it will add a Jerry because we are placing a books. You may think of like that stacking of books. So when you print this dq stack, you see Jerry Tom will be added up here. And also this already we added some of the elements like John, Jane, and Jack. Where I removed one of the element John, I have removed. Jane and Jack will be there. On top of that, Tom will be inserted. On top of that, Jerry will be inserted. The total output will be Jerry, Tom, Jane, and Jack. So when I pop this, the first will be come out. Push and pop will be the stack method. So it will act as a stack also, this DQ, LIFO. When I pop it, like first element will be popped out. That first element we added at last, right? So first, that's the reason it called as in a leaf order. But it, okay, like some of the characteristic we can see. These array DQ does not allow null elements. And it acts as both LIFO and FIFO. That means both stack and queue also. And typically better compared to a linked list because it's a resizable pattern. Okay. For performance reason, we have to use RADQ compared to a linked list. Let's see what is another implementation called priority queue, which is a implementation for queue interface. The priority queue class is an implementation of queue interface that we know. That order element based on their natural ordering. Natural ordering means like in a ascending order or any custom comparator if you pass, it will sort the element based on that, but we can't guarantee it will sort at one shot, but it will sort at the time of retrieving. Okay. Unlike linked list or array DQ, priority queue does not, like linked list and array DQ will maintain an insertion order, but priority queue does not maintain an order of insertion, but instead prioritize element based on their values. That's why it called a priority queue because it will priority based on whatever based on by default better on based on natural order. If you provide any comparator, it will be prioritize ordering the element based on that. So this is syntax of a priority queue, a public class, and we have a method called main method. And I created a priority queue object here, which I'm passing to a reference variable priority queue, which is of type queue, and I'm the type of data I'm storing here in an integer. Okay, we have methods for this priority queue. Offer is a method which nothing but it will do. It will just add a data to the collection. So priority queue dot offer 20, priority dot offer 10, priority queue dot offer 30. So when I print these values, you may wonder like it will always go with the natural order, right? 10, 20, 30 it should be there. But if you print these, you may get like first will be 10 and next will be like we can't give you a guarantee. It will give 20 only or 30 only because what it will do is it just like a lazy ordering. It does not order it at the time, like at the time of insertion, it will does not order completely. What it will do is it will make sure that the first element will be the lowest. Okay. So when you retrieve that first element, it will reorganize and make another first element will be the lowest. I'll show you when I'm giving in a practical demo. So when you print this, you may get like 10, 30, and 20. So when you poll it, means when you take out the first element, you'll get a 10. So next time, if you print the element, you'll get a 20 and 30. Like the smallest element, it will push to first. Okay. By default, it will order elements in a natural order, that is from ascending order. It does not allow null elements. It offers log n time complexity for adding and polling elements. Okay. Let's see the comparisons of Q and DQ and implementations. Order, insertion order, I'm talking about here. Linked list, it's an a FIFO, first in and first out. For priority queue, it's based on priority. by default it's a natural order. If any custom comparator is passed, it will take that order. Linked list, both FIFO and LIFO. Array DQ is also both FIFO and LIFO. So yeah, for null elements, for linked list in both Q and DQ it's allowed, but priority queue and array DQ will not allow the null values. Time complexity O of 1 for all implementation except priority queue. Priority queue will take O of log n for add or remove because it needs to be reorganized, right? So the smallest should become to the first. So when to use, like linked list we use for general purpose FIFO order, like normal linked list queue we use for normal queues like FIFO queue. Priority queue we use when you want to prioritize element based on some condition. Linked list when you want double-ended queue or stack. RADQ efficient double-ended stacker queue. In terms of performance, RADQ will be very good. Well, like final conclusion, Q and DQ interface in Java provides a complete data structure, powerful data structure for managing elements with different insertion and retrieval orders. Depending on whether you need a FIFO, a priority-based queue, or a double-ended queue for both FIFO and LIFO, it's all up to the requirement. Java offers flexible implementation of linked list, which will be acted as both Q and DQ, priority queue, and also RADQ that caters a various use cases. So it's a developer duty to find out which is suitable, which data structure or which collection classes is suitable for my data. It's a developer duty, and this finishes our offset of our collection framework, that is a collection interface and its sub interfaces and their child classes. On our next video, we'll go on map interface, which is another branch of collection framework where the type of data we're storing is totally different. Where in map we used to store in key value pairs. We'll see in our next video. So before wrapping up this video, we'll see the practical of this whatever we discussed. So I have created a class called QDQ demo. So I created a public class here, QDQ demo, and I've created a main method which is of type public static void main. First, I'll use a linked list as a queue in FIF order. I created a linked list object and I'm passing this with the reference variable, which is of type queue, and the type of data I'm storing is a string. John, Jane, Jack added. So the output will be like, we'll see the output. John, Jane, and Jack will be there. After polling a John in FIFO, means I'm removing the first element. The output will be like Jane and Jack. Okay. This is linked list as a queue. Let's say priority queue based on natural order. I just created a priority queue. I'm passing it under queue, which is a common implementation of queue. 30, 10, and 20 added the value using this method called offer. In priority queue, we have method called offer 30, 10, and 20. So when I print this, I'm getting output like this 10, 30, and 20. But we need to consider only the first element. It should always be smaller compared to all collection, like so smaller compared to the entire list, sorry, entire data. So here 30, 10, and 20, 10 is the list, it will come under 10. So I'm just using a poll to retrieve the first element, the 10. So then what it will do is priority queue, it will reorganize and under 30 and 20, 20 is smaller, right? Like it will put 20 at the first for the next retrieval. So at the time of retrieval, it will reorganize into an ascending orders, not at the time of insertion. So linked list as a DQ, we already see linked list as a queue. We'll see how we need to use linked list as a DQ. So I created a linked list object, passed into a linked list reference variable, which is of type DQ here, and the type of data I'm storing is string. I just added add first and add last. Both the end I'm adding first and last, and I'm printing here first and last. On both the end I'm remove first and remove last. Okay, let's see an array DQ as a queue. So obviously it's a queue, means FIFO order will be there, but it's resizable array. I created an object of array DQ, which is of type DQ, and the type of data I'm storing is string. So offer last, because here we have a method called an offer last, means in FIFO order, um, we need to add at the last and we need to remove at the first. Means it's a first in and first out. Okay, John, Jake, and Jack I'm added. When I print it here, John, Jane, and Jack. When I like poll first, the method to retrieve the first element, which removes John, FIFO order. And when I print the array back, like Jane and Jack will be available, the remaining data. So array DQ as a stack. Okay. So yeah, array DQ, like we know, like array DQ implements a DQ interface. So both FIFO and leaf order it will. So our loss instead of that, like if you use push, it will be act as a stack. So Tom and Jerry. When you print this, Jerry, Tom, Jane, Jack, because Jane, Jack already been there. John, we are removed it here at the pole first. So it will retrieve element at the first and it will remove that element from from the data collection. So here Jerry, Tom, Jane, Jack will be there. When I pop it, it will take out the first Jerry and the remaining Tom, Jane, Jack will be available. Let's see the output, guys. So as you can see in the linked list, initially we have a John, Jane, and Jack. After that we remove John, Jane, and Jack will be there. So for priority queue, it's a natural ordering we added, but it will make sure that the first element always be lesser. 10, 30, and 20. I removed 30, sorry, 10. Then 30 and 20 will be there. Later it reorganize and it will become 20 and 30. Next. So linked list as a DQ, first and last are both places we added, and both the at the time we removed first and last. So array DQ as a queue means array DQ. DQ means double-ended queue. It can be act as both FIFO also and leaf also. Both queue also and stack also. For queue, John, Jane, and Jack I have added. Okay, at last. And when I poll it, means I take out the first element, I'm get Jane and Jack will be left out. So array DQ as a stack in leaf order. Here John is already been taken out. Only Jane and Jack will be left, right? For that, I added a Tom first. So Tom will come and sit at the first, and Jerry. So Jerry will come and sit at the another iteration. So Jerry, Tom, Jane, Jack. This will be act as stack. When I pop it out, the first Jerry will come out. The remaining will be Tom, Jane, and Jack. So guys, this all about Q and DQ, and these finishes our collection framework of part, that is collection interface. In our next video, we'll talk about on map and its implementations. After that, we'll move on to some advanced concepts in collection framework. In collection framework, we have a utility classes like example collections class is there. Array utility classes are there. We'll see what all those, and also we'll see how to iterate these collections. So now we are seeing the collections, right? Like how we can able to iterate it. When you have a lot of data, we need to iterate to do some functions. After we storing a data, next step is we need to iterate one by one and do some processing, right? So we'll see in our next videos, and we'll see Java 8 features. After Java 8 comes, how can we use a stream API? How can we able to um, modify data or iterate data? And also, what are the new features up there coming at the existing? And all we'll discuss and wind up this collection framework. But there are a lot of classes will be there. So please guys like subscribe to my channel so that you won't miss a single class. And if you like this video, please share this video to your friends and colleagues. And thanks for watching. I'll meet you in my next video. Till then, keep watching, keep learning. Thank you. Bye.